All right, welcome back to chapter 2. We're going to talk more about the labor supply curve. I'm going to be splitting this chapter up into a few different lectures. I don't like to have too many videos included to make you guys scroll through too much as you're going through the module. But if I just did one long lecture, this would get really, really out of hand very quickly. And I want you guys to be able to retain your sanity and stop wherever you want to. So now that we've done and looked over a few facts about the labor market and talked about some of the measures of labor market health, let's really dig into the worker's decision. That's what we want to do in this chapter. So I'm going to be using the neoclassical model. Now, this is an old model. I'm talking about like the 1800s. So it's very, very old, but it still works. Sorry about that. About 99.9% of economists still rely on this neoclassical model. It's basically one of the most widely accepted models out there in economics, besides like the general supply and demand model. So this is not something that like only a few people believe or something like that. Just want to make sure you guys realize that. Basically, what it does is, despite being simple, it's very powerful, telling a story about how many hours an individual is willing to work based on things like their wages and how much they value leisure versus consumption. So we can compare two options, leisure and consumption. You can do more, and like make it a lot more detailed, but that makes it a lot more complex. So we're just going to split it into the two, basically considering the time spent working as the time spent working that goes straight into consumption, and then leisure considers everything else, even if you're not actually, having fun with your time. So we define utility as the basic satisfaction from an activity. So in this case, the individual receives utility from the consumption of goods, which are a direct result from work in this case, and utility from leisure. So people enjoy a lot of different types of goods and enjoy a lot of different types of leisure, but in this model, we're going to aggregate them all together to simplify our analysis. Like I said, we could break this down into all different types of goods, all different types of leisure, but it's going to get overwhelming very quickly. And in this case, because we're only talking about the decision to work and the decision to not work and how many hours to work, we really just care about if they're working or not. So we're going to use the equation U equals the function of C and L. Looks really weird. This is our basic utility function. It says that you can create an equation. That's what the F for the function means. You can create an equation that shows how consumption and leisure contribute to utility. So both are considered good in this example. So an increase in consumption or an increase in leisure both increase an individual's utility or increase that person's happiness or satisfaction. The idea is that an individual is going to derive utility from both their time spent at leisure and their consumption of goods. So what they have to do is choose between how to allocate their time between work and leisure. So the work is going to generate income, which allows them to consume products or services or whatever. And leisure is something that provides direct satisfaction, time spent not working and enjoying themselves. So individuals face a constraint in the form of time. There's only 24 hours in a day. So the hours that they have to be divided in this case between work and between leisure, which is where the decision-making part comes into play. So because an individual's goal is to maximize their utility subject to the constraint that their total income and consumption depends on how many hours that they choose to work. So indifference curves are a key concept in consumer theory and a key concept in this labor-leisure model that we're going to be working with. So indifference curves represent different combinations of two goods, in this case, leisure and consumption, that provide the same amount of utility or the same amount of satisfaction to an individual. So in this case, the individual is indifferent between any combinations along a given curve because they end up yielding the same utility. And we'll look at a graphical example right after this. So indifference curves help us understand how much leisure an individual is willing to give up in exchange for more consumption, or how much consumption they're willing to give up in exchange for more leisure. There are a few key properties that we should focus on before we really dig into this model. So the first is that indifference curves are downward sloping. They slope downwards because as you consume more of one good, so if you consume more leisure, you have to consume less of the other good, in this example, consumption. if you want to maintain the same amount of utility. So what this reflects is that there is a trade-off between consumption and leisure. More of one means less of the other. The second is that higher indifference curves, or indifference curves to the right, represent higher utility. So the origin is like the point 0 on the Cartesian plane. Right there, that is the lowest amount of utility you can get. As you move away from that to more consumption and more leisure, you're going to have higher utility because they represent combinations of consumption and leisure that provide more of one of those two or both of them. So the more consumption or the more leisure you have, the more utility you're going to have. So the farther out the curve is, it reflects the more consumption or more leisure or more of both that you can do. They're also convex to the origin, which implies that there's a diminishing marginal rate of substitution. I apologize for that mouthful coming straight from the textbook. But basically, what this says is that indifference curves are convex. They're bowed inwards because of the principle of diminishing marginal utility. Now, what does diminishing marginal utility mean? Basically, the more leisure that you have, the less valuable an additional hour of leisure becomes, and the more consumption you'll be willing to give up for more leisure. On the other hand, if you have a lot of consumption, and so you're working crazy long hours and only spend a little bit of time engaging in leisure where you're not working, you might be willing to give up a lot of consumption just to gain an hour of leisure. So this convex shape, where it kind of bows towards the origin, reflects the changing rate as it goes on. So it's not a straight line, it's bowed, it's curved like that, like we'll see in a moment. And finally, very importantly, indifference curves cannot cross each other. So if two indifference curves were to cross, basically what that would mean is that a single bundle of leisure and consumption could provide two different levels of utility, which is impossible by the way that we defined utility or indifference curves. So here's an example of two indifference curves. So we have one indifference curve here and an additional one out here. And again, like I said, because as you move farther from the origin, that's more utility. This second curve has a greater amount of utility. So it's better for that individual. There's more satisfaction. So looking at that first utility curve or indifference curve for the amount of utility, look at points y and x. Those 2 points produce the same amount of utility, even though they're a different combination of work and leisure, because they're on the same indifference curve. What that means is that an individual would be indifferent between y and x, meaning that they have the same amount of utility, same amount of enjoyment from both of those combinations. So at point y, the individual spends $500 on consumption and spends 100 hours engaged in leisure. At point x, they spend $400 on consumption and 125 hours on leisure. Again, because they're on the same curve, they're just as good. The individual doesn't care which of those two they engage in, they're just as enjoyable. They perceive no difference in well-being between the two combinations. They're equally satisfied. Tons of different ways that we can say that they're basically the same. In this case, point y has more consumption and point x has more leisure than the other. But even though they're different, the individual gains the same amount of overall utility from them. So if you're at point X, you make good enough money and have plenty of time for leisure, but your life could be just as good if you took longer hours to work to make more money, to enjoy more in consumption, but you have less time on your hands. So maybe you would move from X to Y because you want to save for a bigger house or save for the kids' college, or maybe just get a new speedboat to enjoy on Cheat Lake. Most people can find cheap fun with a lot of time on their hands, but they can also appreciate making a lot of money. Now, it may seem silly to think that someone could get the same enjoyment from two extremes on the same indifference curve, that they could work long hours, they could have a lot of money for consumption, and also be willing to limit consumption to very little to increase their leisure almost all the way. But that's exactly what happens when a lot of people retire as they move from one point to the other. But getting back to this example, if they're indifferent between points y and x and all the different points on that first black utility curve, what could make the person even happier? The answer would be moving out to an indifference curve farther to the left or above it. So if you move to that blue indifference curve to point z, an individual can increase their utility along every point. So no matter what combination of work and leisure they choose, they're better off than when they were on the first indifference curve in black. So at point z, they get a better combination of consumption and leisure compared to the first indifference curve into points y and x. In reality, this curve should have a ton of different indifference curve moving along each one. So there's a lot in between these two curves. Sorry, I keep clicking here. And there's a lot more going back all the way down to the origin. Okay, so this slide represents something that can't happen. Indifference curves crossing. Remember, if indifference curves were to cross, if two of them did, it would imply that one single bundle of leisure and consumption could provide two different levels of utility. Each combination of goods, or of consumption and leisure in this case, correspond to only one utility level. So they should all be in a line with each other, basically like these two curves, or sets of curves. Now they can have different slopes. Here we have one that's really steep. Here we have one that's a lot more shallow. Some people value leisure a lot more than they value consumption. So we can think about the marginal utility of an activity. So marginal utility may sound complex, but in reality, it's awfully simple. Marginal just means the next unit. So the marginal utility of an hour of leisure is the additional utility derived from as an additional unit, or in this case, an additional hour of leisure. So as we move along the indifference curve, the slope is going to show us the rate at which a person is willing to trade a unit of leisure for a unit of consumption. So we can think of it as how much more consumption to give up in order to get more leisure time. An individual with a steeper indifference curve, like the first one on the left on the slide here, values their leisure relatively more. So it would take a lot more consumption for them to be willing to give up some leisure. The second graph shows the exact opposite situation. This person enjoys consumption more. They'd be willing to receive a lot more leisure time to be willing to give up just a little bit of consumption. So think of the first person as someone who really enjoys their free time. Maybe it's a new grandparent who's really excited to meet their first grandchild. They want to spend so much time with their new grandkid that would take a lot of consumption to make up for it. On the other hand, the second graph is a person that really likes consumption. Maybe they're the kind of person that has to have a new car, a big house, a speedboat, or a fleet of ATVs or something just to feel happy. So they're willing to work long hours for those things. And it would take a lot of leisure time for them to be willing to give up that level of consumption. Now, our neoclassical model here that we're working with glosses over the differences between individuals. And as we work with it later, you'll see we'll just look at one set of utility functions typically. And why is that if there's a lot of different people? Part of it is that we can't directly observe a person's indifference curves. We actually don't know what they are. And doing a survey wouldn't get us anywhere near any sort of accurate representation of someone's actual preferences. A second is that we rely on what we call the typical person, which we call the representative worker in this model. So that individual represents the middle or the average. So if you took the sum of all people's preferences and averaged them across, that's basically what we'd end up with, is this representative worker. Sometimes it may be necessary to compare individuals with different utility functions. So when we do that, we can draw different indifference curves and see how those workers compare to each other. So we look at one here where the person has very steep indifference curves and compare them to a person with very shallow indifference curves and see what the differences are because they have those different preferences. This is something that we won't have to do much of in this course, but I will use it a little bit throughout the slides, just comparing these differences to show what potential differences are going on. So now let's look at the second part of our neoclassical model. After the utility function, we can move on to the budget constraint. Each person has a budget constraint that limits the amount of consumption and leisure that they can enjoy. So there's only 24 hours in a day. A lot of workers are paid a salary regardless of how many hours they work. And most hourly workers don't have a full choice of hours, but typically they have a narrow range of hours that they can choose from. So consumption ends up being limited. We can use the following equation that consumption equals hourly wages times the number of hours worked plus any non-labor income people receive. Now, because there's only 24 hours in a day, this allows us to take another step. The hours worked equals 24 hours minus the hours of leisure. So now we have consumption and leisure in the same equation. Through the magic of algebra, we can write that C, or consumption, equals the wage rate times the number of hours worked plus the non-labor income minus the wage rate times number of hours engaged in leisure. What this tells us is that the line represented by this equation has a negative slope, so it slopes downwards. That slope, or the trade-off between work and leisure, is determined by the individual's wages, which should make sense that we take into account how much money we're going to make when we decide how much to work or if to work or not. So don't go cross-eyed or start ripping pages out of your textbook. I'm going to walk you through this step by step so we know what the equation means. But it is important for you to take away what the outcome from working with the model is. And that's what we're going to be getting to as we go through this. But it's very important in the meantime to set this up with the background. Otherwise, it likely won't make sense, even though it seems like this is a little out there for the time being. So here's our budget line visually, which should help a little bit rather than just looking at the equation. So the amount of consumption is on the y-axis and the hours of leisure is on the x-axis. So here we can see the budget line sloping downwards. T represents the total amount of time. So if this is a day, it's 24 hours. If it's a week, 168, so on and so forth. V is the amount of money that comes from non-labor sources. So it could be allowance from your parents. It could be government welfare programs. It could be stock dividends. Anything that's not determined by your job, money you're getting from outside of that. So even if you devote all of your time to leisure, you can still consume the amount that you earn from non-labor income, which we call point E, because we also call it the endowment point. The most that a person can consume is the sum of the wages and all of the time plus their non-labor income. This is rare because that person would have no leisure time. As we move along the budget line from E, which is called, again, the endowment point, the person is able to consume more and thus works more, giving up some of their leisure time. Okay, we're going to stop there and we're going to pick up with the hours of work decision in the next lecture slide.